In this series of videos, we're going to look at section 3 of the IGCSE syllabus, which is light and waves. We're going to start off by looking at reflection, and then we've got refraction to follow, and then below that we have lenses, which involves refraction, a tiny syllabus statement on dispersion, and just below that we have the electromagnetic spectrum, which was just a lot of learning. After that, there's just general properties about waves, which you can see now. And finally, we have sound as well. So breaking down the syllabus that we just mentioned into a kind of mind map. This is quite a good way to revise. You can try making one of these. It kind of makes you understand the different components and what you know and what you don't know. So in this topic of waves, we start off with reflection, which is what we did right at the start. Then we've got refraction, and in a particular case, this dispersion, which is when you refract light through a triangular prism and it breaks up into all its colours. And then kind of using refraction, so I guess kind of coming into lenses, is refracting light through a lens and what type of images you get there. You've then got the kind of general properties around waves. So this is definitions around wave speed equals frequency times wavelength, what the amplitude is, what is frequency, what is wavelength, and so on. Then there's two types of waves mentioned up here. We've got longitudinal waves and the special type, well, not special, it's just called. We've got sound, and that's the one that we studied around ultrasound and all those different types there. Transverse, well, the special one, well, again, I don't know why I'm saying special, but it is just cool, is the electromagnetic spectrum. So this is made up of different parts. You remember the song? I won't sing it now because it's so good. But this is broken up into different parts, and you learned all about those parts and the fact that they have some things in common, like the fact they're all transverse and they all travel at the speed of light. Okay, so starting off with reflection. So let's have a look at reflection first of all, which is the first part of the syllabus. And let's consider a nice simple start, which is just a nice plain mirror, which means a nice flat mirror, the ones that you normally look at. And let's consider a nice ray, which is a ray of light coming in to that surface. Now the first thing you do, always, is draw, I can hear you saying it yourself, the normal. We normally do that with a dashed line, no pun intended there, normally. The reason why we go to the effort to draw this normal is because we always measure our angles from the normal. So when you get a protractor, you measure that angle there. And we give this angle, the angle between the ray coming in and the normal, a name. It's called the angle of incidence. It also gets a special symbol, I. Now, we know that when the ray reflects off, here's my reflected ray, that the angle it reflects off at, which also has a name, angle of, you guessed it, reflection, and that has the symbol R. So the good news is that for reflection, these two angles are the same, I equals R, so if you measure one, you know the other, and that law, which is called the law of reflection, you need to know for your exam. So that's the law of reflection, that's the angle of incidence equals the angle of reflection. Remember, these angles are always measured from the normal. Do you know what they always do in the exam? They try and trick you, and they give you this angle here. So they might say this angle is 30 degrees. That is not the angle of reflection. The angle of reflection would be 90 minus 30 to give 60 degrees. So careful, they give you this angle here, this one here. That is not an angle that you use in physics. You do 90 minus that to get the angle that we're interested in. Right, so let's now consider the nature of the image formed when a light reflects in a mirror. So let's go down a bit further. Let's go down to there. Over here. Right, let's consider a mirror. There's my mirror. Remember, the dash does not mean the back of the mirror, so this bit here is the front. And let's now consider an object. Let's make it a nice blue object over here, a little dot. And we are looking at the mirror, or the object, from down here. This is a classic physics eye. So, what do we know about the image? Well, we know that the image will be behind the mirror. We also know it's the same size. How do we know that? Well, just look at yourself in a mirror. You appear the same size. You also appear upright. You're not upside down. Your feet aren't at the top and your head at the bottom. That would be strange and pretty useless. We also know that you're the same distance behind the mirror. When you look at that, you're not only just the same size as in measurements, but you also appear the same distance behind. So if you're a meter in front of the mirror, you'd appear a meter behind. The image you see is laterally inverted. What that means is it's not inverted horizontally, it's inverted laterally, so sideways on. There's a nice example of laterally inverted. If you raise your right hand, your left hand goes up. So you're inverted laterally, not horizontally. So your feet don't become your head. And here's another example, though, with words, or letters, sorry. Brown would appear like this. So inverted laterally, so B ends up on the right rather than on the left-hand side. So let's now draw some rays to find out where this image is. Now, because the image is behind the mirror, it appears like the light is coming from there. So we call this a virtual image. And when we draw the images, the lines, sorry, in a minute, you'll see why it's virtual. The light doesn't actually come from there, it just appears to come from there. Virtual also means you cannot project the image onto a screen. Okay, so you can't project it onto a screen. The image is, you can see it, but that's just because the light appears to come from there. So let's now draw some rays onto this mirror. And the best thing to use to do this is, oh, hello, it's even got a little protractor on it. That's cool. The best thing to use to do this is a ruler. So let's pop the ruler in place. And let's just draw a ray coming from the top of my object and hitting the mirror. Now, what we know is that this is going to reflect off this mirror surface. Now remember, to know how it reflects, you need to draw a normal. You could then measure this angle. Oh, you can then measure this angle here, the protractor, and then mark, remember, because it's going to be the same down there. So I'm just estimating, I don't know exactly what it is, but let's go. Well, actually I do, it was 45, wasn't it? So it's going to be, there we are. It's going to be just there, and that's going to reflect off the surface like that. Remember, we don't know which way these rays are going unless we draw an arrow, so don't forget to draw an arrow to represent the rays. Remember, you don't have laser vision. Light goes into your eye always, so that's a good trick. Look for the eye, light's going to go into it. Now, to find out where that light appears to come from, because our eyes are used to light travelling in straight lines, we dot this line back, because we know somewhere along that line the image will appear. Well, to find out exactly where it appears, we need to do another ray. So I'm going to do this one at about 35 degrees there, coming from the same point, hitting the mirror surface. And again, you draw the normal and measure the angles, but I'm not going to do it because I've got this cool little ruler that does it for me. And that 35, there we are, would go down like that. Again, don't forget those cute little arrows to show me the direction of the ray. So to finish this off, we need to dot it back, because remember, our eyes are used to light traveling in straight lines, so we think that the light is coming from here. And this is what we call the image. So it's where the light appears to come from. In this case, it's virtual, and that's why it is virtual, because these rays don't actually exist. It's just our eyes thinking the light's coming from there. The light is actually coming from over here, the object, we call this, but it appears to be coming from back there. Apologies, these lines kind of make it look a bit messy. I'll get rid of those. You can see it a bit clearer. Remember, this is the mirror surface over here. If you now look back at your syllabus statements, here they are. So we've covered all these, the law of reflection. We've talked about plane mirrors and the fact that the image is virtual, and we've performed simple constructs, which is this bit here. Measurements is measuring the angles, and calculations based on those images. So what you really need to do is be able to find where the image would be, and you do that by drawing those lines. If you're not sure, flick back on the video and have a look at that. In the next video, I will talk about refraction. So if we go back to our board here, if we zoom out, you'll see refraction, let's get rid of this ruler, is our next topic, which you can see over there. So we've covered reflection. Now we're going to look at refraction.